Hey, good day, seniors. This video lesson is about the distance between a line and a point. This is actually a very simple lesson. The directed distance from the line ax plus by plus c equals 0 to the point x1, y1 is given by this formula. Now, say your line is this one, the red line, ax plus by plus c is 0. Notice that the line is written in the general form. So by the general form, you mean the right side is 0 and all the terms are in the left side. And the point is obviously x1, y1. The distance between the point and the line is obviously the perpendicular distance already drawn. The shortest distance between the point and the line. So that's the directed distance. And it's given by that formula. Now, in the formula, you notice that there is a plus minus in the denominator. It means we have to choose which sign to use. By convention, the sign of the denominator will be taken to be the same as the sign of b. So the sign of the second term. And this means something. So let's have the examples. Find the directed distance between the line 5x plus 12y plus 2 is 0 and the point 3, 4. 5x plus 12y plus 2 equals 0 is already graphed. Now I use Desmos in graphing the line. As you can see, it's already graphed. So I'll just plot the point 3, 4. 3, 4 is here. Let's make it bigger. This one. This is the point 3, 4. And obviously this line is 5x plus 12y plus 2 equals 0. And it's already written in the correct form. It's already in the general form. So all we need to do is to use the formula d equals a x sub 1 b y sub 1 plus c all over, that's x sub 1 there and y sub 1, and then plus and minus square root of a squared plus b squared. A squared plus b squared. So we have everything we need in this problem. Obviously, a is 5, so that's 5. Usually what I do is just put block spaces 5, 12, and then another block for the coordinates to be inputted, then plus 2. Now you know x1 is 3, so let's put 3 and then 4. Now the denominator says we will choose the sign of the denominator to be the same as the sign of b. Obviously, b is a positive here, so we should pick a positive as our denominator, and then square root of a squared plus b squared would have to be 5 squared plus 12 squared. So all we need to do is to simplify this. So you have 5 times 3, 15. This is 48. So that's 63 plus 2, that's 65. In the denominator, this is a plus. You know this is a triple, but anyway, that's 25 plus 144 inside. That would be 169 inside. And square root of 169 is 13. So we'll get here a positive 5. Directed distance is 5. Therefore, the distance from the point 3, 4 to the line 5x plus 12y plus 2 is 0. This distance, let's put that in red. This is actually 5 units long in length. So there. Now let's have another. Now we have here another line and the point again 3, 4. But this time the line is 5x minus 12y plus 7 is 0. It's already graphed again. I use Desmos. We just have to plot the point 3, 4. The point 3, 4 again is here. So we are expecting a shorter length here. You have 3, 4 and the line. So again we use the formula. So I'll just copy paste this one. So we have 5, two blanks for the coordinates. Now, You have a negative 12y there. So it should be not a plus, but a minus 12, and then blank, and then plus 7. All over plus minus. Now remember, we have to choose the denominator to be the same as the sign of b. And obviously, our b is a negative. So we have to choose negative. And then square root of, again, 5 squared. Plus, actually, this would be a negative 12 squared. Don't forget, it's a negative. Anyway, it will be squared. Anyway, it will be squared. It will still be a positive. So let's just simplify this. So 3 will go in here, 4 in here. So in the numerator, you have 15 plus 7, that's 22. Minus 48, that's a negative 26. The denominator is a negative. And then when you square this again, and then this will be a positive 169, and square root is 13. So you have this. So d is equal to negative over negative. You have a positive 2. So the distance between the point 34 and the line is, this is actually 2 units long. Again, simple, right? Now let's go to the last one. Find the direct distance between 5x minus 12y plus 2 equals 0. Again, it's graph. And the point 72. Now let's plot the point 72. The point 72 is here. Okay? And of course, we are expecting the directed distance to be this distance. So be shorter than the previous two. So this is the point 72. Again, let's use the formula again. Simply using the formula. So we have, it's very important, this should be in general form, which is already is 5 blanc minus 12 blanc plus 2 over, again, the sign of b is negative. So just let's take note of that. That's a negative. So we have to use negative denominator. Then again, this is 5 squared. And then b is negative 12 and then squared. So 7 will go in here. 2 in here. The coordinates. And all we need to do is simplify. We have here 35. You know this is 24. 35 minus 24 is 11 plus 2, that is 13. Now the denominator is negative. 5 squared plus 12 squared, you know this is 169. And the square root of 169 is 13, so you have negative 13. Now we will get here positive over negative, negative 1. Now how's that possible? How did we get a negative distance? We've been taught that the distance should not be negative, right? Now, this is the difference between just saying distance and the directed distance. So we say directed distance, like in physics, you have the difference between velocity and speed. You have velocity, you have to take into account the direction. So it's the same in directed distance. It means something if what the directed distance is negative, and also it means something if the directed distance is positive. So when you're asked what is the distance between the point 72 and the line, obviously our answer is, this is 1 unit long. This is 1 unit. How far? It's 1 unit long. In the previous problem, this is the point is 2 units away from the line. In the first one, the point is 5 units away from the line. In our last example, we got a negative directed distance, but if you're asked just the distance, it's just 1 unit away from the line. Now, very important, you will get a positive directed distance if the point is above the line. See, in the second example, the point is also above the line. But in here, in our last example, the point is below the line. That's what the directed distance means. So let's just summarize that. A positive directed distance, I'm just abbreviating the directed word, means the given point is above the line. And a negative directed distance follows that the point is below the line. So this is very important. The formula is actually very easy and simple to use. It's actually what's more important here is actually to interpret the interpretation to directed distance. So in here, the point is below the line. It's a negative directed distance. In these two examples, first two examples, the point is above the line. The directed distance would be positive. So that's it. And let's continue next meeting. Good day, seniors.